Transform a surface gauge into a squareness comparator. Yes, in this video we are going to cover the tools that you need, the 4 rules to successfully measure an angle. I will demonstrate the 2 methods of measuring squareness. I will show you what you're actually measuring, and we'll talk about cosine error. Wow, that seems like a lot for just a short little video, but it's all packed in here. Before we get started, please take a moment to like and subscribe. Okay, let's get started right now. What tools do I need? You are going to need a surface gauge, a dowel pin, and an indicator. Okay, let's set that up. Surface gauges are basically useless tools as what their original intent is designed for. Once you turn around and you change them over to use an indicator instead of a scriber, all of a sudden a whole new world of possibilities open up. So with this guy here, you can also tell they come in different sizes. When I have an indicator on here, I can turn around and measure things that are parallel. So if I wanted to see how parallel this surface is here, I could run across the top of this surface and it would give me an indication of how parallel something is. So that's in itself is awesome. But the real advantage comes in when you turn this guy into a squareness comparator. There are 4 rules you need to follow to successfully measure an angle. Here they are. Rule number 1, everything must be clean and free of burrs. Another rule is you have to have an extremely clean surface plate. So you should have almost no resistance as the indicator or the part moves. Measure shortest distance to longest distance. You don't want to measure squareness this way. You want to use the shortest distance to the longest distance, not the longest distance to the shortest distance. So you want to be able to measure it this way, the shortest distance to the longest distance. The same as if you were using a square. So you don't want to measure this way, you want to measure this way. Use the maximum distance between the pin and the indicator tip. Another rule is to have the maximum amount of height that you can get. Repeatability. Without it, you don't have an accurate measurement. It's time to measure squareness. There are 2 methods of checking squareness. The first method that we're going to use is the side-to-side method. So I'm going to check this side against this side. So what I'm going to do is I'm going to bring this guy in, roll it in, get a measuring, roll out, double check, roll in, roll out. So that's just a hair under the 0 mark. I'm going to rotate this 180 degrees, roll in, roll out, roll in, and I'm just a hair above. So that means, let's say it's 1/10 above, 1/10 below. So therefore, this guy here is out about 1/10. Now, the second method is using a known object. So I know that this guy is perpendicular or square. So I'm going to use this guy to get the 0 on my indicator to check a second piece. So I'll bring this guy in here, roll in, 0 out here, right on 0, check it. So I'm just, right about there. There we go. So now I bring the part over that I want to check. So let's say this doesn't have a second side, or this side has got some kind of bump here or something, and I can't check it the other way. So then I'd roll in, check, roll in, check. So I'm about a 1/10 out of square on this guy. And that's the second method of checking. Okay, so we know that this guy's good to within a 1/10. So what I'm going to do is I'm going to put this piece of paper on this side here. And now this guy's going to be out. How much is it actually out of square after I put that piece of paper on? And I want to measure and get a physical number. So I bring this guy in here, make sure they both, see I'm not touching here, so that's good. I picked the right side. So I bring this guy down, I go to 0. I don't know if you guys can see that or not. There we go, I'm at 0. I do a test, roll in, roll out, roll in. Always got to have repeatability. Rotate this piece 180 degrees, roll in. So now this guy's measuring approximately 16.5. So it's 16.5. This is telling me that this is out 8.5 thou. So 16.5 divided by 2 is 8.5. What are we actually measuring when we use this method? So what are we actually measuring? So this becomes a hard stop. Our indicator is a flexible stop here. So we're measuring the difference in distance from this height here inside to this pin. So when I measure on this side, I get a reading, record the reading, flip the part around to the other side, get a reading, divide that dimension in half, and that's how much you'd be out a square. Let's review the math one more time. The indicator on the left-hand side is 3 thou. The indication reading on the right-hand side is 2 thou. Therefore, we add the 3 thou plus 2 thou equals 5 thou. We divide the 5 thou by 2, and you come up with 2 thou 5/10. Therefore, the block that you are measuring is out 2 thou 5/10 out of squareness. What about cosine error? No, we didn't forget. So now I know what you're going to say. Hey Ray, what about cosine error? As long as the tip stays perpendicular to the body within about 10 degrees, it's really not that much of an issue. And for about 95% of all squareness comparating measurements, it's not really a factor. As great as this is, the next generation is so much better. The actions are a little bit smoother. I will be featuring this in one of my upcoming videos, and I will also be posting the STL files. Hopefully you found the video as entertaining as you did educational. If you want to see other great videos, check out my YouTube channel, Shop and Math. If you haven't subscribed yet, why not? Please take a moment to like and subscribe. It's free and it'll help me out. All you have to do is click on the icon on my face and I'll do the rest. While you're at it, click the bell, get notifications as well. Thank you for watching the video, and have a great night.